Hello everyone, welcome to AI Anytime channel. In this video, we're going to look at MapReduce implementation in LangGraph. Now, most of the time you are going to work in production and there are some tasks which has to be, you know, decomposed and they have to run in parallel. So imagine if you have a very big task, it's a large scale task that you have to solve through AI agents or, in general. Then what you do, you divide that or you decompose that, in smaller tasks and then execute them parallelly. That's what we're gonna see in this video through an algorithm called MapReduce. So MapReduce implementation within LangGraph. Now, the interesting thing here is that why LangGraph? Because LangGraph has come up with something called Send API that I'm gonna cover that in a bit. No, it's not that without LangGraph you can't do it. You can do it, but then there will be challenges. Now, just to give you a bit of idea, if you don't know what LangGraph is, so LangGraph is a library for building stateful multi-actor applications with large language models. So right now we are living in the era of AI agents. It's a hyped word, and of course it has its value. We have been seeing the values. Now there are different frameworks or libraries that you can use to build AI agents, starting from LangGraph, Crew AI, again, Crew AI based on LangChain, by the way. So LangGraph, Crew AI, AutoGen by Microsoft, Agency Swarm. You have a lot of other frameworks and libraries that you can build agents. Now, LangGraph is stateful. So when you compare to other LLM frameworks, it offers the core benefits like cycles, controllability, and persistence because it has statefulness in it, so you can persist. So persistence is there. Now it's very different from DAG-based solutions. If you know about acyclic graph, direct acyclic graph, if you're aware, that's called DAG, by the way. Uh, LangGraph allows you to define flows that involve cycles. That's very essential for most of the agentic architectures. That's what LangGraph is, and it's based on Apache Beam. Like the public the public interface has been inspired by Network X. Network X, again, if you have worked with some graph-based projects, you will know in Python. So LangGraph is again built by LangChain, by the way, so creators of LangChains. Now, here is what I'm going to do first. I'm going to install a few libraries. If you look at here on my Colab notebook, I have LangChain Core, LangChain Community, LangChain OpenAI, LangGraph. So it will install and then I'm gonna import a few things over here. So let me just do that. Now this is important for us to understand, guys, that when you take it to production, there are bigger challenges. As I said, the large scale task, we have to decompose task, run it parallel, so parallel processing and all of those things. Now I'm just gonna load this, import this here. So what I'm importing, I have some utils like base pydantic for data validation. I will define some structures, some classes. Chat OpenAI as a large language model, we're going to use GPT-4o mini. And I'm using LangGraph send. Okay, so that's a send API that we're going to use. And then we have langgraph.graph import end state graph start. We're going to talk about end start and state graph in bit. Now, you need an API key to follow along this tutorial. If you want to use OLlama, you can also use OLlama. Just run an LLM in background, here in terminal if you want. If you're on Colab Pro, you can access this terminal. You can run an LLM and then you can use through that model, OLlama model through LangChain that runs on a port. Okay. Now, just to keep it simple, just for you to get the idea, I think I missed a couple of more imports. So import OS and then from google.colab import user data and then os.env. I'm going to set the key in environment and that's called OpenAI API key that I have stored in secrets that you see here in the left hand side. There's a key called secrets. That's where I have saved it. And then you're going to do user data.get and inside this just call it OpenAI underscore API key. It will ask you to grant access now. I'm going to give grant access, and it basically access has been granted. Now let's define a model here. So model thingy here, chat OpenAI, and then we define the model name, which is nothing but GPT-4 GPT-4o and then mini. And you can see my model is has been also defined. Now I'm going to define a few prompts. So I'm going to show you the steps. So what I'm going to do, I'm going to take the prompts here. I have some just to save some time writing those lengthy prompts. Now let me explain this here, what I'm doing. I'm just going to get rid of this here. Now step one prompt. I have a problem related to input. So input is something that you will take it from the end user. So if you are building a front-end application or if you're building a CLI-based application or whatever tool, you will take an input. Input is nothing but the problem statement. Now imagine the large problem statement. I come from India. I'm based out of India, and we have multiple cities where we see a lot of traffic problems. If you talk about Bangalore, for example, has a huge traffic issues right now going on in the country. Now in the city, by the way, if you talk about Bangalore, and there are other cities like Mumbai and whatnot, but if you ask AI to solve these kind of problem, then it has to go through multiple steps, multi-agentic flow. It has to look at a lot of case studies, the real problems, the statistics, the numbers, the time period, the time duration of people who go to offices, there are some peak hours and whatnot, right? So these are bigger problems. An agent cannot immediately, a single agentic flow or a single function cannot solve this problem. You have to, decompose or I'm not say divide. You have to decompose the bigger task into smaller tasks and let it run. So if you look at here, what we are doing, the first one, I have a problem related to input. Could you brainstorm three distinct solutions? So the first is three distinct solutions. Please consider a variety of factors such as perfect factors. And this perfect factor, again, we're going to, basically declare or assign there in the below cells. Now, step two, for each of the three proposed solutions, evaluate their potential. The people come and say on social media that, let's do work from home in Bangalore to curb the traffic. So that's the one solution that we can propose. The second solution is that probably changing a bit of time on the office peak hours, dividing it like some offices can start like 8 to 9, 9 to 10, 10 to 11, blah blah blah. I don't know. That's the second solution. The third one is what China has uh, China has been utilizing in Beijing, where they have a guy who will come on a bike and will rescue you, and somebody will drive the car, later. So something like that. Okay. Now consider their pros and cons. So you have to consider their pros and cons. Initial effort needed, implementation difficulty, potential challenges, because a lot of risks are associated. You cannot just build a solution and deploy it in production. There are a lot of things that you have, a lot of variables involved. Assign a probability of success and a confidence level to each option based on these factors. So that's what it does. Now it gives you the solution here for this, and then there is step three prompt that you see it over here. Step three, for each solution, deepen the thought process. So we're going to deepen the thought process, generate potential scenarios. We're going to just do a lot of hypothetical A/B testing kind of a thing, scenario one, scenario two, testing it out, strategies for implementations, partnership required with some other government entities and whatnot, or even the corporates, right? If you talk about the particular problem statement, uh, and then it evaluates based on the evaluations and scenarios, rank the solution in order of promise, provide a justification for each ranking, and offer any final thoughts or considerations for each solution, and then the detailed analysis. So let me just run this prompt here. You can take this prompt will get changed, guys, depending on your use case. So if you have a different use cases, it will change. Here I'm trying to look at more of a public transport and kind of a thing, for a city. Now once you define this, the next thing that you're going to do is you're going to define the output structures of what kind of solutions output you are looking at, the review, the deep thought, and whatnot. So let me copy these classes. I have a bunch of classes over here, and I'll just copy this. Now, if you look at this, the first one is class solutions, which take the base model as an input for all of these that you see here. Now solutions, which is a list item that you see. Review, which is nothing but the string. Deep thought should be string, and ranked solutions should be string. So we are using base model from Pydantic to do data validations over here. And then I'm defining the overall state. So input, perfect factors, these are all the strings that you see. Solutions, list item, list item, list item, and the ranked solution, which is a string. And then I'm just defining the state for individual solution processing. So all of these solution steps that you have. Let me just run this here. And once you do that, you have to define the function, the graph component. So I'm going to explain that in a bit. That is important. Now I'm just take me graph component. Now if you look at the graph components here, guys, first is generate solution function, which takes a prompt, step one dot prompt, format it into input, and then has a perfect factor associated with it, and then model dot with structured output, blah blah blah, and all these functions that you see, this will be from top to bottom. And when we visualize the arc, you will understand what I'm saying. Now it has four functions: generate solutions, evaluate solution, deepen thought, and rank solution. And then continue to evaluations and continue to deep thought, defining the mapping logic. And and you will see that once we draw the diagram. Now once this is done, we're gonna construct the graph. So I'm gonna write that code here. I don't have that handy. So construct the graph. So once you have that, you're gonna construct. The first is state graph that we're gonna have. So let me just construct the graph here. So the thing is graph dot equals, and it will show you can see state graph, and we're gonna pass overall state over here. So let me just pass overall state. That's right. Now this is my, and I'm gonna add node. So graph has nodes and edges, guys. If you are somebody who is beginner, I will recommend you learn graph theory. It's very important in data structures and algorithms as well. You should focus on that. Uh, Let me just do graph dot add underscore node. You can see it has conditional edges, and we're gonna use all three of these conditional edges, which will have conditions associated with it, edge and node. So let me just do first add node, and the first node is nothing but the generate solution. So let me just do generate underscore excuse me, you're gonna take generate underscore, I'm just gonna copy this here, guys, be a bit fast in writing. So generate solutions, and then I'm gonna just use the same thing here. Okay, generate solutions. So you can see this is fine, so I'm just gonna copy paste here. So not copy paste, by the way, it was suggesting me. So graph dot add node, you're gonna add it for all depend thought rank solutions, blah blah blah. Now our nodes are defined. Now we're gonna add the edges. So what I'm going to do is graph dot add edge. You can see this is what it's showing. I'm just going to remove this first. Now I'm going to show this. Now it's an add edge, and then we have our start. That's what we imported on top here that you see start. And if you come down, and then the first thing is generate solution. That's where it start. Okay. Now I'm going to add conditional edge here. Now add conditional edges. Now in conditional edges, I'm going to use continue to evaluation thing. It has to continue and evaluate. So edges, and you can see evaluation. So I'm going to write generate underscore solutions. I hope I'm writing it right. Maybe might some typo. If there's typo, it might give you an error. Continue to evaluation. Continue to evaluation, and then you pass your evaluate solution. This is right. So I'm just gonna run this and then have couple of conditional edges, evaluate solution and generate solutions that you see. Now continue to evaluation and continue to deep thought and evaluate solution and deepen thought. That's what I'm writing. Now I'm gonna do graph dot add edge, and then you have deepen thought and then rank solutions. This is fine. Then you add one more as edge, which is rank solution, which is end, and that's what we're going to end it. Now this is how you construct the graph. Okay, we started with an overall state, basically initializing the graph that you see here. and then has for node, and then has edges, conditional edges, and edge that ends. So let me just run this here, guys. I'm run it. Now I'm just gonna do, once you run it, you have to compile the graph. So you do have to graph.compile. You can see it has compiled, which is a function. So I'm just gonna run this. Now I have compiled it. So you can see, you can find it out all of your verbose here for this given app, everything over here. So if you want to go a bit deeper into it to understand, you can also do that. Now I'm gonna call the graph now. So call the graph. Now in call the graph, I'm gonna have for s in app.stream. I'm gonna use app.stream, and it takes a dictionary. You can see it says input dict string any. Programming is easy, guys. If you look at this, it says dictionary. So the first thing you have to do is dictionary, right? So let's do a dictionary here. Now I'm gonna pass my input, and then you have to give an input. So I'm gonna give improving public transportation in a growing city. Now, if a growing city, how can we improve the and then you also have to give perfect, you have to give perfect factors. You can change the use case, probably not perfect factor is not the right word. Then you have cost. You have to, you cannot take a, you know a project which has billion of dollars involved, right? You have to build a cost effective initiative that you have to take. And then you have efficiency, and then environmental impact. It has to be sustainable solutions. You cannot just start burning a lot of resources. Environmental impact, and then after environmental impact, you also has to take care of user experiences, guys. But that's very important. Just look at, if you look at all the best solution that we have seen so far in the world globally, these are all these are all how should I put it, having the best of user experiences. Canva, ChatGPT, these are all the best of user experiences. Now we are okay with this. Now what I'm going to do is I'm going to run this and see what it does. Okay. Now if it gets an error, then we're going to try it out, and we'll see, hopefully. So you can see it generating the output for you. Okay, generate solutions, evaluate solutions. Yeah. Now if I just take this ranked solution, you can also do a pretty print, guys, for the rank solution. But let me open this in Word file. I want to read this. You can use pprint to print that, in better ways. Now, if you look at the rank solution, I'll make this a bit bigger. So the rank solution says expand the existing public transportation network with electric trams or light rail systems. Justification, it gives you the justifications. This solutions addresses the growing demand for public transport due to urbanization and technological advancement. It has a high potential for success if implemented with community support and financial backing. And the phased development would happen, not the entire city should not be covered in one go. However, economic downturns could delay progress, and careful planning is needed to mitigate funding constraints. I'll just make this in next line. So that was the first one. So let me just make this for you so you can understand this a bit. And two, and then you have three. Yeah, and this looks nice. Okay. Now, if what it says, this is the first thing that it says, three solutions, and it has gone through a bunch of reasoning and all. Okay, thoughts, and let me just copy this. Justification can go on the next line. Yes. Let me just bring justification. And I'm just gonna remove this thing here. Okay. Let me just remove this thing. So you can parse the output through JSON and all. That's fine. Uh, but that's okay. That's fine here. Okay. Okay, cool. I think we are good. Now this is what it says. The ranked solution. It says expand the existing public transportation network with electric trams or light rail systems. It gives you justification. And the next one is implement a bus rapid transit system. That's called BRT. And the BRT system can effectively reduce congestion and increase public transport uses, especially if it integrates with smart city technologies like IoT powered. And this is good. And then launch a bike sharing program like rentals or or bike sharing, shared bike. Like in India, we have a lot Rapido and stuff. Dedicated bike lanes. Probably this is something that and docking station. I think this is improving. This is right. Okay. Now this is a bit generic, and this is all your output, guys. If you want to go through all the output, it will be huge. It will be multi-pagers because it has to go through a lot. Okay. Now let me open a new file here, Word, and then let me just do a blank document. Now you can find out here for each of the components. So this first generate a solution, bus rapid, and then goes through a lot of things. Evaluate, and then evaluation happens, you can see, and then evaluate solutions, blah, blah, blah. This is great. And then deepen thought for each of the steps. This is fantastic. Now you can see how you divide it in and all of these tasks run parallel. Now, if you just want to visualize it, and if you want to visualize the architecture, so what you're gonna do is from IPython display dot I need image from IPython dot display import image, and then I'm gonna do image, and I'm just thinking that it should suggest me when I want it. It doesn't suggest app dot something get or something they have, right? Get graph. I think yeah, get graph, and then it's a graph, so I'll prefer mermaid. You can see draw mermaid PNG, and this is how it looks like. I'll just save this image by the way, guys. Start, generate solutions, evaluate solutions, depend thought, rank solutions, and end. This is fantastic. I loved it, guys. Now this is what I wanted to cover. How you can break down or decompose the task. You can see it over here in different prompts that we have defined, and it uses send API. So if you want to read more about it, guys, you should read. You know, Recently it came up. I don't know if it's here, but yeah, you can go through the documentations and you can read a bit more about it if you want. You can see here like this is that send API. These guys ask a question. How to send details from one node to multiple nodes in parallel. That's very important, guys. And you can read something, here you can see a related API, the send API, which makes it easier to do map reduce like work. But this is fantastic, but not relevant for his use case, but this is what we are doing here. You can look at this. Okay. And that's fantastic, right? Now, if you have any question, thoughts, feedbacks, let me know in the comment box. This is an early morning video, guys. It's like very early here where I live. Just wanted to create something for you guys. Now, the code will be available on my GitHub repository. Uh, and you can also join our Discord community. I will give the link in description. Growing community, guys. We help each other. We have a lot of internship, job opportunities, freelancing gigs available, and a lot of learnings, by the way. Now, if you like the content, please hit the like icon. If you haven't subscribed the channel yet, please do subscribe the channel, guys. That motivates me to create more such videos in near future. That's all for this video. Thank you so much for watching. See you in the next one.